All right, so last one in the group. Again, another one where the negative sign gets cut off. So I'll bring that over here. On this one, we have to strategize a little bit. So we're trying to go from ice to water, and we're trying to go across, a lot of temperature range here, more than 100 degrees shift in temperature. What we need to notice from this is that it's not going to be possible under normal circumstances to take ice that's at negative 30 something degrees and bring it all the way to 70. It's also not normally going to be possible to make water at negative 30 something degrees. So we're going to have stages here where we have to take the really cold ice. Sounds funny to, in Texas to say that we've got to warm up the ice, but we do. We have to bring it to negative 32 degrees up to 0, and then we have to melt it, right? So this would still be at 0 degrees when we do the conversion over to swap to water. And then we have to go and warm up the water. So if we check our number of arrows for a number of different changes, we have 1, 2, 3 processes that we have to factor in. So our first Q is going to come from warming up the ice, and that's going to be MC delta T. All right, so the mass is 1182.13 grams. Because it is solid ice, we have 0.50, like we saw in the earlier question. It's not the same as liquid water. And then the change in temperature from negative 3283 up to 0 is just the positive version of that number because we have to warm it up to 0. All right, then we have to have a certain amount of heat to melt the ice. So mass and then latent heat of fusion. There is no temperature change. It'll have the same mass because we're looking at the same sample. Then we have our latent heat of fusion, which is again, oops, I put the wrong units though. That magical constant, and then calories per gram, not any Celsius. So ironically, I put Celsius. It's the only thing that wasn't supposed to be there. And then there's not a temperature change. So there's nothing at the end of this. Same here, no temperature change. And then last part, we have the heat that gets pumped into the water to warm it up. So we've got MC delta T for that one. All right, same mass. Then specific heat for liquid water, which is what we'll be dealing with here, 1.00 calories per gram degrees Celsius. And then the change in temperature from 0 up to 73.39 is in fact just 73.39. And so if we can find each of these three answers, then we can combine them and then we can find the overall total for how much heat this is going to take. All right, so for our first step, looks like that's going to be 19,405. For our next step, 94,334. Then for our third step, 86,757. Then putting all those together, 200,496. And because of rounding error, occasionally this answer will be off by 1 or 2. But when you're already in the hundreds of thousands, the singles, the ones digits, not going to make much of a difference.